Recording in progress.
So guys, we are starting with the next part of exponential and logarithmic limits. So currently we will work on this formula. Limit x approaching 0 log 1 plus x the whole upon x, which is equal to 1. Okay, one small example. Limit tell me how to solve this.
Multiply, divide by 3.
Correct, because there is 3x over here. I'll multiply and divide by 3. Okay, so this part as per this formula will be 1.
Into 3.
Into 3, which is 3. As x approaches 0, 3x will also approach 0. Okay, we'll take some problems from the worksheet. Okay, so exercise number 9. Let's take some easy problem to go ahead with. Exercise number 9, question number 12. Limit x approaching 0, sorry, 1. Rather, just wait. I'll take you to question number 22, sub question 1. 22, sub question 1. Limit x approaching 0. So in the numerator, root minus some term is there. I was surprised yesterday in the revision,
Rationalize.
I was not able to remember this rationalization and all. Rationalize this. So if we group this, a square minus b square, the final answer of this will be x. If you do a square minus b square, cancel out 1. Okay, so the final answer will be x. This should be 1 plus, sorry. So limit x approaching towards 0, x upon. Now this is the logarithmic term. So upon x into x. We require x. We require x down over here. So upon x into x. Fine. So now some
So I have a
cancellation.
doubt.
Ask.
So why can't you just use the formula method? Why do you have to multiply and divide by x?
Which formula method?
Like because it's here, it's x by log 1 plus x, right? Why can't we use the formula only?
That's
Which is
not a
log.
direct formula. You can, if you want to use, you can use that. Not a problem.
Hmm.
Okay, I'm keeping a standard method.
Okay.
Okay, so that the entire crowd does not get confused. Okay, so this particular thing is 1 as per the formula. This and this is gone. Now 1 upon. I'm applying the formula over here. So 1 upon 1 into. What to do with this?
Substitute 0.
Put x as 0 because it will not create an impact, as in the denominator will not be 0. So root of 1 plus 0 plus 1. So this will be 2. I hope everybody understood this. Question number 12 from the previous page. Question number 12. Limit x approaching 1, x minus 1, log x to the base e. No need to write a d over there. That's fine. It's understood that the base is e. Okay. Now this is in itself question number 20, sub question 2. So both the questions are same. Both the questions are same in the worksheet. Okay. So we have a logarithmic term. If we put x as 1 over here and log 1 will be 0. Okay. So that is one challenge, 0 in the denominator. This cannot be further simplified by some means. We cannot apply any logic or any formula to avoid this 0 situation in the denominator. So we are left with only one choice, either LHL or RHL. Let x is equal to 1 plus h. As x approaches 1, h will approach 0. Limit h approaches 0, x is 1 plus h. So 1 and 1 is gone. There is h over here. Divide by h, multiply by h. This and this is gone. We are left with 1. What is this part? What is this part?
Log h.
Log x.
1.
That's 1. The formula is not log x. The formula is 1. So question number 12 and question number 20, sub question 2 are covered up. Question number 14. Question number 14. Limit x approaching 5. Log x minus log 5 upon x minus 5. Now if you put 5 over here, 5 minus 5 is going to be 0. Any simplification is not really possible. Okay, you can do log a minus log b is log a upon b, but then that will not help us further. You can apply that property, but then it will not help us. It will be pointless. RHL. As x approaches 5, h approaches 0. H approaches 0. Okay. Now you may apply this. Log a minus log b. Okay. Now some students might have a doubt that why we did not do it earlier. See, even if you do it earlier, you will have to do RHL. So you do it now, you do it earlier. Log a minus log b is log a upon b. You do it now or earlier. RHL तो करना ही है. Log a minus log b. Log a upon b.
So then you split the denominator, and in the denominator you.
Wait. Let everyone understand. I'll go very slow. This is a very tricky situation. Log a minus log b is log a upon b. Now here Just remember, we are going to split limit. So somebody said that was absolutely right. Good. Log phi upon phi plus h upon phi upon h. Log 1 plus h upon phi upon h. Guys, if you write like this by mistake, this is wrong. Huh? This h is for the entire denominator. So don't write anything. Now our format is log 1 plus x upon x, provided x is approaching 0. Same value should be down. So here if it is h by 2, if it is h by 2 over here, नीचे क्या रहना चाहिए?
Divide
If
by
h by 5, sorry, h by 5, denominator should be what?
h by 5, so that multiply
Correct.
divide.
H by 5 should be there. So out of which h is already there. H is already there. Sometimes h won't be there. Now h is already there, so just we have to multiply and divide with 5. Because h is already there. This part, what is this part?
1.
This part is 1 upon 5. As h approaches 0, h upon 5 will approach 0. If you want to practice some problem like this at home, I'll just give you one problem. Do it at home later on. Question number 19. Question number 19. Limit x approaches 0. This is the question. A is greater than 0 is what they have given. We'll do log a minus log b right at the beginning. Log a minus log b is log a upon b. This we have done in class as well. This week itself. We have to eliminate this a because we require 1 over here.
You can take it out the bracket.
So we'll take that common. Okay. So we'll take out that a as common term. So in the numerator, take a common. 1 plus x upon a. I took a common, but then x does not have a. So x
What
upon a.
about log?
Log is there. Log is there. I forgot writing it. Okay. Then a 1 minus x upon a. Okay. I've written this incorrectly actually. The bracket should be only on top. Yeah. So small things matter. We'll go wrong in the calculation somewhere otherwise. A will get cancelled. Now again, this is a situation of log a upon b. But then in the reverse way. Earlier we merged it. Log a minus log b is log a upon b. Now we are going to expand it. What is log a upon b?
Log A
Log a
minus
minus
log
log b. So log a minus log b. That I will write on the next step, on the next page. Limit log 1 plus x upon a minus log 1 minus x upon a upon x. Now split.
Sir,
Yeah, tell me.
I had a doubt. So since the formula is log 1 plus x, uh, so can we, for the second one, can we write log 1 plus bracket minus x upon a?
One and the same thing. One and the same thing. Correct. You can write. Okay, guys. Now be ready for the discussion. This is x upon a. So this should be what?
X upon
X
A.
upon a.
Out of which x is already there. X is
So we
already there.
multiply divide by a.
So only a is required. What is this along with the minus sign?
Miss you so you can do minus bracket
It is minus
plus.
x upon a. So I'll make it minus x upon a. But then we'll have to multiply with minus a. Guys, did you understand this?
Yes, sir.
Yes.
This part. This part is what?
1.
Again, this part.
1.
So 1, and then you multiply the minus.
Correct. So basically, one note I will write down. X approaches 0. So x upon a also approaches 0 and minus x upon a also approaches 0. Okay. A is a non-zero value. A is greater than 0, which it is mentioned in the problem. They have to mention this. So this is compulsion. You have to mention this. So 1 upon a minus 1 upon minus a. 2 by a. Similar type of a problem, you can practice it at home. I'm just changing this problem a bit. This time I'm taking minus first and plus next. So you can do this at home and check what is the impact. I have covered up logarithmic problems. Now there is one last formula
In
where we
this
need to
one, we'll
take
have
some
to take
efforts.
RHL, right?
No, this is the same problem only.
But it's x tends to 7.
Oh, sorry. I'm sorry. My mistake. X approaches 0.
In the previous one, the method we were doing, the log 1 plus x by a upon 1 minus x by a is wrong, right?
Why wrong?
Because you get 1 by a as the answer when you do that method.
No, in the worksheet also it is 2 by. This is
Oh,
right.
okay.
And I have solved also for you. See.
Oh, yeah. Okay.
Next one. Okay, so this is the next formula. The last formula of exponential limits, logarithmic limits. So how does this formula apply? There should be 1, 1, same, plus should be there, x should be same. Okay. X approaching 0, 1 plus 2x upon raised to 1 by x. Tell me how to solve this. This is 1, this is 1, this is
In
plus.
So in the power we do into 2, divide by 2 into 2, right?
So we are having 2x over here. We'll make this 2x and this is also 2. What about this then?
E.
E, provided x is approaching 0, e raised to 2. E raised to 2. Yeah. So as x approaches 0, 2x will also approach 0 because we applied the formula for 2x. Okay. So this is the main theme. Let us take some problems from the worksheet. Question number 16, sub question 3. A very simple problem. X approaching 0, 1 plus ax, b upon x. Now, if this is 1, this is supposed to be 1. It has to be 1. So first we'll eliminate that b. B is in the numerator, so I'll write in the numerator. If b is in the denominator, I'll write in the denominator. Now this is plus, that is also fine. Ax. So this should be ax. This should be ax. Eliminate this a by writing a over here. Are you understanding? Yes or no?
Yes.
Yes, sir.
Now this part is E and this is AB. X approaches 0. AX also approaches 0. Sub question 3. Indices. Indices. A by B raised to M. A raised to M. B raised to M. So make this 5x square. Multiply by 5, divide by 5. Multiply by 3, divide by 3. Okay. This and this is e raised to 5, e raised to 3.
E raised to 5 minus 3, which is e square.
E square. X approaches 0. So 5x square will also approach 0 and 3x square is also approaching 0. Because if you put x as 0 over here, it will be still 0. Guys, did you understand this problem?
Yes, sir.
Yes, sir.
Yes,
So
yes, sir.
Chalo, great. One last problem, that is an extra problem I forgot to include in this worksheet. It is not from any textbook also, it is a randomly created problem. But then do this kind of problems, whatever I'm teaching you. I've taught in class. Limit x approaching 0, 3 plus x, 3 minus x, 2 by x. Now we require 1 over here.
Yes,
What
so
to do?
3 are common.
Take 3 common. 1 plus x by 3. 1 minus x by 3. The whole raised to 2 by x. Now what?
You remove the 2 on the top and
We
multiply
cancel
by
3.
3.
We cancel out 3. Now indices. This power will be given to both. This power will be given to both.
So isn't it? Huh.
Okay. Now 2 is not required. What is required over here in the formula?
So by x by
So
3.
1 by x.
1 is required. 1 is required. Correct. Because it is 1 upon x. So first we are going to eliminate this. Two and we'll make it 1. Okay. Now this is plus x by 3. What should be this value?
The x by 3.
It has to be x by 3. So I'll divide by 3, multiply by 3. Denominator. I don't have space, so I'm just putting a division sign. 1 minus x by 3, eliminate this 2. 1 upon x into 2.
Divide and multiply by -3.
Minus x by 3. So this is minus x by 3 upon minus 3. Upon minus 3. This is what?
E.
E.
And what is this?
E.
So this is going to be e raised to 2 by 3 divided by e raised to minus 2 by 3
e raised to 4 by 3.
Yeah.
a raised to m divided by a raised to n m minus n m minus n. And write that note, x approaches 0, so x by 3 also approaches 0 and minus x by 3 also approaches 0. So this is one extra problem from my end. I'll give you one problem to practice at home. Copy that and do it at home. That problem is this. You can do this at home as practice.